Hey everybody, welcome back. This is Cool Coder, and today I'm looking at LeetCode 424 longest repeating character replacement. So I'm going to assume that you've already read this problem and just explain it in my own words. So essentially we're given a string and we are given an integer k, where k is the amount of times we can replace a character in our string. And what we want to do is return the length of the longest substring where every character is the same after we've made k or less than changes, right? So in other words, in this example, we have A, B, A, B, right? And we can make two changes. So we're going to change the B's and make them A's. And we have a length of 4 where every character is A. Let's look at this example down here. So let's look at this substring. So in this substring, how do we know that we can replace a character and have a substring where every character is the same? Well, so let's look at it. So if we replace the A's, right, we have to make 3 replacements for them all to be the same. So if we replace 3 A's with 3 B's, we have to make 3 replacements, and now they're all the same. However, that's not going to work in this case because we only have one time to make a replacement. So let's look at the B. So if we replace the B, we only have to make 1 change, right? And this whole substring, all of the characters are going to be the same after we make 1 replacement. So we can, in this substring, make k changes where all of the characters will be the same character after we make the change. Let's look at this substring, right? So you'll notice we added another B. So we want to change the B to the A, right? Because it occurs less. If we change A, we have to make 3 changes. If we change B, we only have to make 2. So we're going to change B, right, to A here. But you'll notice that we had to make 2 changes and we only are allowed to make 1. So this substring does not work because we don't have enough times to make a replacement to make all of the characters the same. Okay, so now let's figure out how we're going to tell how many changes we have to make. So like in this substring, we have to make 2 changes. Well, we're going to do that by taking the window length. So the window length is 5. There's 5 characters inside this substring. And we're going to subtract it by the number of the most occurrences. So we're going to find the number of occurrences of A because A occurs most, and that's going to be 3, right? This is before we replace anything. So there's 3 A's, and this is going to equal 2, right? So in other words, if we have a substring of length 5 and every single character is an A, then we have to make 0 changes. But in this case, we have 3 A's here, and so we're going to have to make 2 changes in order to make every character in the length of 5 equal A. So that's how we're going to find out how many changes we have to make in a given substring. Let's look at this substring here. So you'll notice the window length is going to be increased to 6. The amount of occurrences of the most is going to be 3, and that'll be either A or B. So you can pick, but it's going to be 3 either way. And so this is going to equal 3, right? So now we have to make 3 changes for them all to be the same. So we can either make changes on the B, and that's 3, or we can make changes on the A, and that's also 3. So that's how we find out how many changes we have to make. And once we have this number, we can go ahead and compare that to K. If we have to replace a character, if we have to make 3 replacements on a substring, then we need to have greater than three amount of times that we can make the change. So right now we only have 1, so this substring is not going to work, right? Because we have to make 3 changes, but we're only allowed to make 1. So that's how we're going to figure out what changes need to be made and how many changes a certain substring we would have to make in order to make all of the characters the same. So let's go ahead and walk through this kind of step by step. So we're going to go ahead and start with basically 2 pointers. We're going to make our left pointer start at 0. So I'll just annotate that here, and then we're going to loop through every single character in the string. So and we can use just like a right pointer here. So what we're going to do is we're going to update a hash map. We're going to make a frequency hash map, and we're going to update that with the character at the right index. So the right index is at an A, so we're going to update the frequency map. And then we're also going to update the largest count, and the largest count is going to be the max of the current largest count or the number of the characters at the right index, right? So it's either going to be the greatest count is either going to be the current character that we're at or the previous greatest count. So right now greatest count is 0, so 1 is going to be greater, so this is going to change to 1. And then we're going to check if the window, right? So the window is going to be right minus left plus 1. So right is 0 minus left, which is 0 plus 1. So our window length is going to be 1. And we're going to check if window length minus our greatest count here, we're going to see if that is less than or equal to k, which is 1. So obviously 0 is less than 1, so we're good. So we're not going to increment our left pointer. But if this value is ever greater than 1, then we're going to have to increment our left pointer. So in this case we don't, so we're good to keep going. And then we're going to update our result, and we're going to take the max of the current window length, which is 1, or the result. So 1 is greater than 0, so this will become 1. And then we're going to go ahead and move our right pointer. So our right pointer will now be here. And then we're going to do it all again. So we're going to update our frequency hash map. So A will be updated to 2. We're going to get the largest count. So again, the largest count is currently 1. So what's bigger, the previous largest count or the count of the value at our right pointer? So the value at the count of the value at our right pointer is 2, right? Because we're at A and A is 2, so we want to replace this with 2. So that's how we're going to keep track of our greatest count or our largest count. Then we're going to check if the window length, which is changed, so right is now 1 minus 0 plus 1. So that's going to equal 2. So our window length is 2. So we're going to see if 2, which is the window length, minus the greatest count, the largest count, which is 2. We're going to see if that is less than or equal to k, which is, so it's still 0. So 0 is less than k, so we're good to go. And then we're going to update our result. So result is going to be the greatest of result or the current window length, which is 2. So this is now going to be 2. So now we're going to move on. Our right pointer is now going to be at B. And we're going to update our frequency map. So there isn't a B, so we're going to add that. B is 1. Our largest count is going to either be the previous largest count, which is 2, or the value of the right pointer, which is only 1. So we know that A occurs twice, B only occurs once, so we want to keep the largest count at 2, which is why we're going to check the previous largest count versus the current count that we're at. So largest count is not going to update, it's going to stay at 2. And then again, we're going to check the window minus the largest count. So the window is going to be 2 minus 0 plus 1. So window count is 3, right? And that makes sense, right? This window count is 3. And we're going to take 3 minus the largest count, which is 2, and see if that is less than or equal to 1, which it is. So 3 minus 2 is 1. 1 is less than or equal to 1. And this makes sense, right? So in this current window, we have to make one change for them to all be the same. So this substring is good. So then we're going to update our result. Our result is going to be either the current window length or the previous result. Current window length is 3, which is greater than 2, so we're going to update that. So we're going to keep moving. Our right pointer is now at A. So we're going to update A here. Okay, so then we're going to update our largest count. So what's larger, 2 or the value at A? So A is 3, so we're going to update that. So largest count is now 3. And then we're going to check again the window length minus the largest count. We're going to see if it is less than or equal to K. So again, window, the right pointer is at 3 index. The left pointer is at 0 plus 1. We're adding 1 here because it's 0 index. So we have a length. So currently we have a length of 4. But if we don't add 1, then it's going to show that our window is only of size 3, which isn't true. Our window is size 4. So that's why we add this 1 here. So then we're going to subtract the window length minus the greatest count. So greatest count, the window length is 4, greatest count is 3, which is still 1. 1 is less than or equal to 1, so we're good to go. So then we're going to update our result. Our result is going to be the greater of the current result or the window length, which is 4. So the result is now going to be 4. And then we move on. So now we're back to that first substring that isn't going to work, right? So we're going to update our frequency map. So B will be 2. The largest count isn't going to change because the current value we're at is 2 here, because our right pointer is at B. The value at B is 2. So we're going to take the greater of the 2, either the current count or the previous largest count. So the previous largest count is 3, so it's greater. 3 or the current value, which is 2. It's 3, so greatest count is not going to change. And then we're going to check if the window minus the current greatest count is less than or equal to 1, right? So the window size is going to be 4 minus 0 plus 1. So our window size is 5. And so we're going to check if 5 minus the largest count, 3, is less than or equal to 2, or is less than or equal to 1. And we'll see that 2 is not less than or equal to 1. So this substring is not going to work, right? So now we have to make a change. So if this is true, what we're going to do is we're going to update our left pointer. So the value at our left pointer, we're going to decrement the value in the frequency map. So our left pointer is at A, so we're going to take 1 away from A. So we're going to go here, and then we're going to update the left pointer. So now that we've updated our left pointer, we're going to continue on. We're going to get the largest count. So the largest count is going to be the greatest of the current largest count or where the right index is, which is 2. So 3 is greater, so we're not going to change that. And then we're going to check if this condition again. So the window is going to be 4 4 minus 1 plus 1, which is going to be 4. And then we're going to see if 4 minus 3 is less than or equal to 1, and it is. So we're good to continue. So we're going to then update our result. So our result is going to be the max of the current result and the window length, which is 4, and it's the same, so this is not going to change. So then we're going to continue on. So our right pointer is going to move. We're going to update our frequency counter. And then we're going to update our largest count. So either 3 or this 3. So it's not going to change. It's going to stay at 3. And then we're going to check if the window length, which again is going to be 5, right? Because we're at 5 minus 1 plus 1 is equal to 5. So we're going to take 5 minus 3, which is 2. And 2 is not less than or equal to 1. And that's correct, right? So in this case, we have to make 2 changes, right? We have to make this change and this change for all of the characters to be the same in this substring, which we don't have that amount of changes to make. So that substring is not going to work. And so this is going to continue on. That's the process of how we're going to solve this. And the result is not going to change in this scenario, but this is how we're going to solve it, right? So the time complexity for this is going to be O of n, because we're looping through the input array once. And then the memory is going to be at worst O of n, because we're creating a frequency map of the input string. So if every input string is different, then we'll have to have a frequency map of every input. So that's why our memory is going to be O of n. Okay, so like I said, we're going to have our frequency map. We're going to have our left pointer, which will start at 0. And then we're going to have the count of the character that occurs the most amount of time. So we can call that max count. We'll start that at 0. So then we're going to loop through the input string. And we can call the pointer right for clarity. So then once we're in our loop, remember we're first going to update our frequency map. So this is just saying we're going to get the current value in our frequency map, and if it doesn't exist, then we're going to return 0 and add 1 to whatever is returned. So then we're going to update our max count, which is going to be either the current max count or the value at our right index. So we're going to take the max of the current max count, or the value, the character at the right index could become the character that occurs the most amount of times. So that's why we're going to take the max of either the current or the value at the rightmost index. So then we're going to check if our window minus the max count is greater than k. To get the window size, we're just going to say right minus left plus 1. So if the window size minus the max count is greater than k, then we're going to decrement at the left pointer, right? So first we're going to take away the value in our frequency map at the character at our left pointer. And then once we do that, we're going to increment the left pointer itself. And then we're going to update the result, right? So let's make sure we add our result here, starting at 0. And our result is going to be the max of the current result or the window size. And that's it. After this, we can return the result, and that should work. Let's run it and make sure. And everything worked. That's awesome. This was a pretty complicated problem, I thought. So I hope y'all learned something. I hope you enjoyed watching this, and hope to see you on the next one.